morning, everyone. Thank you for attending the AI Day, and welcome to my presentation. My name is Luis Beltran. I am a Microsoft MVP in AI and developer technologies, and today I'm going to explain the topic machine learning and deep learning for the C# developer. I hope that this presentation is interesting for you. So let's get started. And also, thank you to all the sponsors that support this event. Without them, this would not be possible. Of course, also thank you to you for attending this event. I hope that you get a lot of knowledge and that this conference gives the best for you and for your knowledge. So, okay, a little bit about me. My name, as I said, is Luis Beltran. I am from Mexico, but currently I am living in the Czech Republic because I am pursuing my PhD at Thomas Bata University in Zlín. My research area is about artificial intelligence, focusing on face recognition and emotion detection with deep learning, actually. So we use a lot of convolutional neural networks, TensorFlow, and some other technologies that we use every day. I am also a lecturer at Tecnológico Nacional de Mexico in Celaya, and I really love and very passionate about mobile application development with Xamarin. Also, cloud computing applications with Azure, and of course, artificial intelligence. Here you have my email, luis@luisbeltran.mx, in case you would like to reach out or you want to be in touch if you have any questions about this presentation, or if I can collaborate with you with anything about these technologies, mainly .NET or Microsoft technologies. Yeah, feel free to send me a message. So, okay, the agenda is very simple. First, we will briefly talk about machine learning and deep learning, and then we will go to ML.NET, which is a technology for us, let's say developers, C# developers, or even F# to work with and implement machine learning. Okay, so machine learning, as you know, belongs to the artificial intelligence area. The idea of machine learning is to focus on building applications that are not explicitly instructed to detect if there is a dog or there is a cat in a picture, or if this text has a positive sentiment or negative. Yeah, actually, the applications or the models learn from data. They apply or use algorithms that extract the features of the text or the pictures of data, let's say, in general. These algorithms extract the features that determine, okay, with this image, what is inside, or this text, what words are used, and are they positive or negative, and so on. So usually in our data, we can have two types. We can have labeled data or non-labeled data. And respectively, they mean, or if they are used for machine learning, we will talk about supervised learning or non-supervised learning. Basically, when you provide the label, this is supervised learning because you are specifying in your input, for example, this image belongs to a dog, this other image belongs to a cat, and you continue because, of course, you have to provide a lot of data, let's say 1,000 pictures of each class, let's say. And then when you apply the algorithm, of course, it will be associated. This is the group of dog pictures. This is the group for cat images. Then let's analyze. Let's differentiate. Let's build some difference to understand. So the algorithms or the model will understand the features for cat, the features for dog, and when a new image is provided, it will know what is inside. So yeah, that's the idea. You can predict. In machine learning, there are several tasks. One of them is classification. The picture example is classification. Also, you have you know this. When you check your email, some of the messages arrive to your inbox, and there are others which are sent to the spam folder. Every time that a new email arrives to your, let's say, or is sent to your address, the server analyzes the metadata of this message and determines, depending on the content, if it's spam or not. That's also a classification or example. There is a prediction, for instance, when a machine learning model uses data, historical data, let's say the product price, the variation of product price through some time. And the objective, the goal is to predict what is the price for next month or next period of time. So yeah, you can predict some number applying some techniques such as regression, for instance. And there is also clustering, which is part of the non-supervised learning. And the idea is that you don't know the label information. You don't know if there is a dog, there is a cat. You just know there are pictures, and clustering will group them based on the similarity. Okay, so for instance, there are text examples like, okay, which of these papers are similar in topics? So you can group them using clustering techniques or algorithms. That's the idea. Also, you have seen this in, let's say, online stores. So there are, when you are recommended some products, it's because you belong to, let's say, some profile, or the website creates a profile from you based on where are you connecting from, what products did you buy before, or if you are new, you will belong, let's say, to some group or category of customers for targeted marketing. That's the idea of these product recommendations. And then we have deep learning. Deep learning is part of machine learning algorithms, but mainly uses neural networks, artificial neural networks. So, of course, the idea is to build models that think like human. This requires, usually a lot of computation power, because you are not using only one neural network. You are using several layers, several number of artificial neural networks. But they are quite effective in discovering patterns, especially when you have to analyze thousands or even maybe hundreds of thousands of data, such as images, mainly images, but also video, audio. Yeah, a lot of it can process a lot of information. Deep learning is usually applied, or the hardware that you use are GPUs, because of course they are also powerful for mathematical operations, for calculations basically. And if you apply a normal machine learning technique to this type of data, it will be slow. And deep learning is, let's say, optimized for these scenarios. The idea is that the layers perform both feature extraction and classification. In machine learning, traditional machine learning, these are separate steps in your, let's say, pipeline. But again, you can use deep learning for prediction or for classification. Yes. And well, there are a lot of tasks that are performed in the deep learning structure or basic structure. The idea is that, for instance, you have a picture, and through the process, through the pipeline, it will discover the features that determine what is inside, for instance, inside this picture, and maybe create or discover the feature that will determine, okay, is this input or output a picture? And it applies some mathematical operations, you will see in the next slide. But how it determines low-level features, okay, it actually goes from low level into higher level features. So you can see, for instance, that we have perfectly defined picture, and this one is decoupled into, let's say, detecting edges or converting this picture into another format, which is called convoluted image. You will see in a second. And yeah, it will start extracting some features. This is actually, as I said, some mathematical operations. So you have your input image, you apply a filter, you determine, okay, we have this matrix of data. My filter is 3x3 matrix, and you know that the image, of course, is also a data matrix. So you will perform, or you will separate your input data in groups, and you will apply mathematical operation here. So the filter will start moving. You select some piece or some part of your input image, and then you apply the mathematical operation through the input image. And you will create another matrix of data, numbers. And if you create an image from it, you will get this convoluted image. That's the main idea. Then you can perform some operations, which I did not include here, but if you read the documentation about deep learning, you will find, for instance, the pooling. In order to discover, let's say, or the mid-level and then higher level features, there is pooling operation, which basically takes, let's say, 3x3 space, 9 elements in your convoluted image. And if you apply max pooling, it simply selects the highest number of this group of 9. Then it moves to the next, let's say, 3 by 3 elements to the right. And then it extracts the highest value and so on. The idea is, of course, you have a matrix of this size. And if you split, or if you create groups of 3 by 3, select the highest, then next group 3 by 3, yeah, you are reducing the space or the size of this matrix. Then you can apply convolution again, max pooling, and at the end, you will have a smaller matrix, which represents the input image. And it will you will build, or it will detect the highest features. So yeah, usually when you have convolutional neural network, for instance, you will have combination of convolution, then pooling, convolution, pooling, and so on. There is another technique, which is average pooling, which instead of, in this case, instead of taking the highest number, it calculates the mean or the average, of course. And this number represents the group of data. Okay, so this is just brief introduction about deep learning. Then we have ML.NET. And ML.NET is a technology from Microsoft where you can leverage your C# or F# knowledge to create machine learning applications. Of course, you know that in the AI world or machine learning world, Python and R are the main languages that are used for development or for creating these algorithms. Well, ML.NET is another option, focused, of course, on developers that want to include machine learning in their applications. One of the advantages is that this is an open source platform, so everyone can contribute to it. You can see the roadmap. You can see in the GitHub or repository of this project. You can fix some issues. You can check what's going on. But the main advantage is that it's cross-platform. So this means that your application, you can create .NET Core applications, and it can run on Linux, on Mac, or of course on Windows. You can then take the model that you create with ML.NET and publish it to the cloud, for instance, any cloud, not only Azure. You can also maybe deploy it to your local server and have an on-premise machine learning scenario. It is quite common that the model that you create with ML.NET, you can take it, for instance, to an API project, web API, if you know about C#, and then expose it as a service. So maybe a mobile application written in Xamarin can, of course, connect to the web API, send some data, use the model inside the server, and then calculate or return a result, machine learning result, of course. So yeah, that's the main advantage of this technology. It is quite easy to start with ML.NET. All you need is to add the Microsoft.ml NuGet package in your application. And then you might add some extra libraries or packages, depending on the type of application or on the purpose of your code. If you want to perform anomaly detection, which is another machine learning task, you will definitely include this package, Microsoft.ml time series, because of course you will analyze data in time. If you want to create a recommendation scenario, there is Microsoft ML Recommender. If you are working with image computer vision, you might add this combination of language packages. In our case, for instance, we are going to use Microsoft ML TensorFlow, a TensorFlow C# version with the project C# released, and yeah, maybe ML Vision or image analytics. If you want to consume TensorFlow models, because that's also another advantage. If you have created a TensorFlow model, you can consume it. You can have it in your machine learning project, C# project. And this was something that came with version 1.4, which is the access to data from database. Yeah, because of course, you can take data from files, you can read information from files, CSV files, text files, memory, but it is now possible to directly connect to a database in SQL Server or MySQL. I believe Cosmos DB is also supported. Yeah, there are several database providers that you can use to get or load your data from. After you add this, the main object that you are going to use in your application is the ML context, which is the starting point of all operations. You create an instance of your ML context, and you can use all the functionality that we will briefly explore. Of course, you can load the data, you can train a model, you can, after you train it, you can predict. And yeah, this is what actually we're going to talk. How do you load data? Well, you have to know that the data is represented in an iDataView object, which has three characteristics. It's high dimensional because, of course, you can load many features. Maybe you have your columns, so you can take a lot of information and load it in memory. But actually, it's memory efficient. It actually applies lazy loading, which means that if you have, let's say, 1,000 data, 1,000 rows of information, when you load it into the iDataView, in memory, you will not have this 1,000 data at all. It will read what it needs at a specific time. So maybe it takes groups of 100 data, and then it reads the next 100 and so on, because at the moment it is analyzing this group of information. So yeah, that's the idea about lazy loading, and it's also immutable, so it doesn't change. It is loaded. And yeah, this actually, regardless of where your data is coming from, it will always be represented in memory as an iDataView. Then you can do a lot of operations in ML.NET. It is also important to know that you apply, in order to use the iDataView, you have to create a class, but basically this model or this class represents your data. Maybe you have these 5 columns: flower type, sepal length, width, petal length, and petal width, and you create a class. The name is not important, but this attribute, load column attribute, which that specifies, okay, this is the property for first column, this other property for second column, and so on. So you have to decorate your model with this attribute. Then when you add the code, you will have the data loaded into this object in memory. You will see in a second, in a minute, about the code. Then we have the I Estimator and I Transformer. You have to create them through your code. Basically, the I Estimator is a plan. You can see it's like a blueprint where you specify what operations are in your pipeline. You know that your data, you don't usually apply it directly to the model. You don't apply machine learning on it. It is raw data. So sometimes you have to normalize it. You have to convert your features or your data into some features, or I don't know, convert numbers into categories, for instance. Or maybe you want to replace missing values because maybe in your data there are a lot of nulls, and of course you can't use nulls in mathematical operations. So what do you do with them? Do you turn them into zero? Do you calculate the average and replace nulls with this value? Maybe you don't want all your columns, so you drop them, you create, or you can even concatenate some of them. These are classical operations in machine learning. So yeah, the I Estimator is basically, okay, my pipeline will perform this on the data. And the I Transformer is when you apply this plan, let's say. Okay, it's the execution of the operations. Then in ML.NET, there are a lot of trainers. The trainer is basically the conjunction between algorithm and task. Okay, so maybe you have algorithm, stochastic dual coordinated ascent, or maybe you have a neural network or others. Then in which task you are applying this algorithm? Okay, binary classification. Then the trainer that ML.NET will use is SDCA, non-calibrated binary trainer. Maybe later you want to apply this algorithm, but with another task, such as multi-class classification. Okay, yeah, it's possible. Then SDCA non-calibrated multi-class trainer will be created. Maybe you want to apply it for prediction or regression. Okay, there is SDCA regression trainer, and so on. So yeah, this is possible. You will see in the code. And finally, we can export the model that when we perform the machine learning, we can export the model and reuse it later, or take it to the cloud in the scenario that I described a few minutes earlier. This model, it's a zip file serialized that contains some of the information that I just mentioned: data schema, data transformation, and algorithms. And you can build or create different types of applications that use this model. It is worth saying that currently the mobile scenario is not supported at all. For instance, as I said, I cannot create a Xamarin application that has this ML model directly. It is not possible yet. So the workaround is to take it to a web project and expose it as a service. But I know that they are working on this, so maybe in the near future, it will be possible to integrate this model directly in our mobile application for offline machine learning tasks. Okay, and before we go to the demo, it is possible to implement deep learning or train deep learning models using ML.NET. Basically, we are going to leverage the knowledge that is acquired by pre-trained models, such as Inception version 3, ResNet 101, and apply some techniques such as YOLO, for instance. You only look once for image classification, for object detection. You will use the TensorFlow API, but in this case, there is a TensorFlow transform that uses C#, of course, and communicates to the C++ API. So this is, let's say, high level. You communicate with this, and internally it is translated into C++, or it's called in the C++ internal API. So let's explore the demo. And if you have questions, you can, of course, write them in the chat. And after this demo, I will try to answer them the best I can. So in this project, you can see some models, some Nugget packages. You can see Microsoft ML, ML Image Analytics, ML Vision, and of course, C#, TensorFlow. We have some models. We have car image. This car image is based on this CSV file. This CSV file, okay, it's not open. Sorry about that. This CSV file has 3 columns. Just give me a second. Yeah, it is here. 3 columns, or three types of data: image, class, and subset. The image is basically a path, which you can see here. It's the image folder, and then maybe this one. So you can see this picture, which has some kind of broken lamp or glass. Yeah. So this is an issue that a car has. We go to second image. There is also this problem. Yeah. And actually, this is label data because you have picture and the class. Okay, so in the first example, there was headlamp issue. Second one, door scratch, and so on. And this subset is because my data, I'm going to split it into training and validation set. You see the B. So in this case, I am modeling these columns. Yeah, my input data. We have these 3. Then we have the image prediction. This is, of course, for the result. This is the image path for newer data, the actual damage class, and the predicted label. Of course, this second column will be compared to the predicted label of our model, and we can see if these 2 match, it means that is correct. This is used for validation, as I said. Later, when we have newer data, this will be empty. We will just submit the image path, and we will get predicted label. And then we have our code, which is this program. Here I have just some paths. As you can see, is where my data is, the CSV file, the folder of images, and then I have something for testing later. And this will be the output. So the zip, the zip file will be created in this path, and this is just a log, but I didn't use this one, I believe. Okay, so here you can see I create load data method, which basically just read the CSV file and creates a list of car images. Okay. Which aligns to my model. So I have a list of this information here in memory, but this is just a list. This is still no ML.NET. This is just classic C#, because I'm just reading a file. Then, this print message, of course, just to display some output. This is the main code. As you can see, there is ML context instance, and then I call the load data method. So I have a list of car images. I split. This is again just normal C#. I create two lists, one for training, second one for validation, applying some LINQ code. Yeah, the T, the B. And this is the iData view that I mentioned earlier. There is load from enumerable method. You can see also the load from database. Well, if I added the ML.NET the system.data.sql client, I would see here load from SQL, load from database, method. Well, actually, yeah, I see it. Create database loader is different. Yes, create database loader. But in this case, I want to load from enumerable. I could have also used directly load from text file, but I don't want to because I have to split before the information. Or maybe if I have training data in one file and validation data in other file, I can directly go for this other method. Okay. Then I create two iData views, one for training, second for validation. This will be used later. At the first point, I will focus on training. Then I create the iEstimator. You can see this pipeline. In this case, I am applying just some transformation. What is actually doing? I'm going to open the images. Yeah, there is load row image bytes. You use the path of the for each row, and it will open it and save the information in byte array. Of course, you know that the picture is byte array. Then we have some options for image bytes. Just the encoded label. This is when we are going to apply the deep learning. I am saying, okay, please reuse the knowledge or load this pre-trained model based on Inception version 3 architecture. This is the deep learning part actually, and you can see it's very easy. And some other parameters, such as to avoid bottlenecks, you can reuse some data in cache. And yeah, well, I can also display some useful information maybe about the training process or some metrics. The learning rate, for instance, you can get it with this line. So yeah, this is the loads pipeline. Then we have training. Okay, yeah, training options, training pipeline. Here I create encoded label column based on damage class. Damage class, of course, comes from the input. And of course, we also create predicted label because we want to know what the model says there is in the picture. And yeah, we have the append is just joining to the two pipelines, loading and training. But nothing has started yet until the fifth method is called. So the fifth method performs or executes all what we said before. Yeah, so far here nothing has happened, but this method, this is the one that will take a lot of time. After the training is completed, we usually validate our model. In this case, we transform it. Yes. So we use the iData view validation set that we created before. We print the metrics of our model to see if it is correct or if we have to improve it. Yes. And yeah, the rest we just print the accuracy value. And we perform some image classification with new data. Yes, in this case, you can see that I have a predictions data view, which is from different path, actually. No, actually, this is still part of the validation. Sorry. This is part of the validation. So we are comparing the actual class. This is supervised learning, so I know this data, and what the model said. Yes, so you can see if this was correct or not, if this was successful or not. You can compare it. We can export the model, very simple. Context, model, saved. We have the model, and we have the schema. This, I mentioned that this is one data, and the path. And finally, and this consuming model, this is the code that we will use, let's say, in another application, because we load the model. If there is save, there is load method. Yes. And then we use this model again that was loaded from the path to analyze new data. Yes. You will see in a minute some new pictures. Actually, they are from here. There is test, yeah, card test. Yeah, you see the pictures. They are not used for training, of course. These are just different subset, and let's see if it works. And the classify images is just using creating the engine from the loaded model and the predict method. Yes, so I will run it. Actually, I'm not sure it will take a lot of time because it took around maybe 15 minutes, but I know that it saves in cache some information. Yeah, so yeah, it might take some time, but well, I also create a screenshot for it. I can share the presentation, of course. So yeah, as I said, I'm not sure how much time it will take because it takes they are around 1,500 images. Yes, yeah, it will take in this time. But yeah, sorry, I can show the results here. In this case, for these 4 pictures, you can see this is bumper dent. This was predicted. This is door scratch, glass shatter, and tail lamp. And the metrics are here. This model is the accuracy is 69%. So of course you can improve it. And well, yeah, I wish, I wish it was possible to show it live, but yeah, it is taking some time. Sometimes it's quite fast because this was in memory, but I restarted the computer, so probably, yeah, I will get some error. Yeah, yeah, my memory is too high, so I might delete something. But yeah, you can see later the presentation. I can share the code, of course, on GitHub. And well, there are some resources here that you can check later to get started. There are a lot of samples in GitHub or also in the documentation on Microsoft. And there are a lot of videos and tutorials. And well, that will be all from me. If you have any questions, please let me know. I will be happy to answer them.
Hi, Luis.
Hello, Valencia. Yes.
Hi. I can share some question. If you give me only 1 second. Okay. I don't know if you can see my screen. Okay.
The first. Yes, I can.
Yes. Okay.
Yes.
This is the first questions. Okay. How about hardware acceleration on the edge applied to MLNet library, like Intel Neural Stick 2 or similar? There are some, is supported, not, or if you have some info about this.
Yeah, that's a good question. Honestly, I have not used the hardware acceleration part. I'm not sure if it is supported. I know that, for instance, you can apply transfer learning. So maybe you train a model in better hardware, and then you can reuse that knowledge into this ML.NET, let's say, new application, and just replace the last layer, the output layer, with new training. And maybe it will take just a minute or 2 minutes, depending on the, let's say, new amount of data. But the idea, of course, of transfer learning is to create general models for it. So I don't know if this can be like a workaround. As I said, I have not checked if hardware acceleration is supported, but maybe if you have some better hardware, you can perform all the training there and just create a smaller model in ML.NET with C# maybe. But yeah, or you can just send me a message and I can ask or research this for you.
Okay. Another question is how much images do you use for training?
Yeah,
this is an interesting question, I think.
Yes, yeah. As I said, there are like 1,500. Yeah, well, but I split. So 1,000 for images for training and 500 for validation, or maybe lower number. It depends on the CSV, but it's more or less those numbers.
Okay, and you can give us an idea which number is a good number for training?
Yeah, usually you will find 70%. Yeah. Best results I have accomplished is between 70 and 80% for training, and then the rest for validation.
Yes, but how much images do you think is a minimum for a good
I understand.
network, a good training?
Yes, the quantity is fine.
I don't know. There is
also
no magical number. I don't know.
There is no magical.
There is no magical number, but
my results more than 1,000 is better. But of course, also the quality of information and the diversity. That's also important. Yeah, the variety of your data.
Okay. Okay, we don't have other questions, so I think we can close this session.
Okay.
I'm very happy. I think your session is very interesting for me and for people. So I can tell you thank you for this session.
Thank you for having me.
I hope we see you in next event.
Definitely. Let's be in touch. Send me an email, follow me on Twitter. Yeah, I will be happy to collaborate later. So enjoy the AI Day. Thank you again for having me, and see you.
Bye.
Goodbye.
Bye.